Welcome, everyone, to Excode Week 4, Getting Technological. Just give me a second, just getting this to work. Thank you all for coming. And this week, we're going to look at flow control, Boolean logic, that stems from flow control, and then also looking at loops, mainly for loops and while loops. We're also going to look at program examples, and we have an engineer from Meta coming to do a guest talk, in addition of also announcing the Excode game competition. So to start, we're going to present a code to make the rain stop to go down. So rain equal to false. No, I wish, but thank you all for coming with the rain today. It's much appreciated. I hope you're not too much soaking wet. Unfortunately, it's not possible in code yet. We don't live in a 3D utopia, but that will be nice. And thank you all for coming with the rain. So this week, we're going to start with presenting indentation. So you probably already see some of indentation in week 1. We talk about the fact that spaces in Python mean something. And this is different to other programming languages that have other methods. But it's important as a prerequisite for this session, because it is important for you to understand that in Python, we represent block of code through something called indentation, which basically means putting space for things that pertain to the same block. So in code, when you see a block of code, if you see lines that have space before, you know that they are part of a block of code that starts with this first line that starts at the start. So you can see here at the top, we have blocks. So this is a block of code. And then we have parts of that block of code. And you have that space here means that this part is part of this block. Here you can also have nested blocks. So the first one with the body, and then this block is nested inside of this other block. And so this line of code is within this two, while this line of code is only within this block. This is important because it will allow you to really quickly understand how the code is structured and how it works in the things we're going to present today. And it's also important because sometimes you may have indentation errors. So if you see indentation error, you know that it's due to the fact that you don't have a right space, or most of the time we also use 2 points here, the 2 dots. So if you have this symbol, it's part of the block as well. So maybe you're missing it. So if you see this type of errors, indentation error, you know it's because of spaces. And the first thing we're going to use indentation for is flow control. And I believe this is one of the most important elements that we're going to see in Excode, because it is helpful in plenty of scenarios. But even beyond that, beyond coding, it is something that we kind of all take for granted. And when you need to apply this to programming, you learn a lot. And you learn a lot about this fundamental concept that we call logic. So you all have some experience, at least I hope, with logic. I mean, we use it all the day. For instance, we can go really simple. I mean, always taking the box here. If the box is empty, I put the bottle in the box, it is safe to assume that the bottle is the only thing in the box. If now I take it out, it is safe to assume that the box is still empty. I can give you some examples. If I tell you that I'm always a liar, I always lie, and then I tell you the box is empty, well, you can deduce that the box is not empty. There's something in the box. So what we've all done here is we've used our logic, our decision-making ability, to apply our knowledge based on a situation. So we were given information, a box, the fact that something is in a box, logical statement. You use that to make your own logical conclusions, to say, oh, the box is empty, or it's not empty. This is really important because for us as humans, it may be basic, but then when you apply this to computer, it allows computer to kind of simulate making decisions. That's why we call decision-making within computers. And we can say this as advantageous or disadvantageous, but computers, they won't lie. I mean, if you have a condition, that condition will be true or false. And it's not like a human where we have a more holistical approach to decision-making. A computer, if you can single out, at least at this level, if you can single out the condition, you can then single out and understand what will logically happen, which makes it simpler for us to interpret a computer than it is to understand maybe a human being making decisions, because through a computer, we can look at how it makes those decisions and then understand his logic. So we talk about the high-level, abstract understanding of flow control. And now we're going to reconnect it with an actual usage practical use case. And through those two, you will truly understand what it means. So let's say I want to have a logic where something different happens in two different scenarios. So let's say this is a number line, and this is representing age. So if someone is over 3 years old, I want to do something. Maybe you can watch this movie. And if you're under 3 years old, you can't watch this movie. Is an example. There could be plenty. So I want the computer to make kind of that decision for me. So I don't have to go manually and decide for every single person. I have a logical, and I want the computer to apply its logic to this case. So that what I will do is I will use flow control to define two scenarios. So I take number as input, and then I say, oh, if it's true, if the number is bigger than 3, then I run some code. If it's false, if the number is lower than 3, then I run some other code. And you can see here how we apply our own logic to a computer in a really simple way. We're defining a condition, and we say, if this condition is true, then I do something. I run some code. For instance, I print, you can watch this movie. If the condition is false, then I do some other code, and I print, you can't watch this movie. And we use something called an if-else in Python. So if true, this code, else if false, this other code. So in terms of actual written code, this is the syntax we use. Let's take another example. I'm going to take the name of someone as an input, and I want the name in my startup to be longer than 3 characters. If it's lower, maybe it will. I think it's not the real name. I know there are shorter names, but maybe this is not the best example. But let's say in this scenario, I want names that are bigger than 3. So I'm going to write an if-else. So if the name is bigger than 3, then true. I'm going to print hello plus name. If the name is lower than 3 characters, I'm talking about characters, so length of the name. If it's lower, I'm printing error. Your name is too short. You need to put your name again. So this is an example where in an actual use case, in a startup or in a dashboard, you have that control. Another example could be for an over 18 website, where you're checking, enter your age, and then if your age is over 18, then you can access. If it's under 18, logically it's false, the fact that you're over 18, thus you cannot enter. And there's plenty more examples we can give. And now kind of consigning of the abstractual and practical implementation of flow control, what it means is to control the flow of the code. So different things will happen based on logical conditions. Let's look at some code. So here is how we write an if-else in Python. It's quite actually simpler than other languages because we simply have the if. So if the condition, then you can see we have indentation here to say that's now you can connect how indentation is useful because we know that here this code will happen only if the condition is true. And then else and this code will happen if the condition is false. So if you take name as an input, what is your name? We check the length of the name is over 3. If it's true, then I print welcome plus name. If it's false, else, I print error name too short. We can have the age checking where I take age as an input, turn that into an integer with casting that we saw in week 3, and then check, is it over 18? This code will run only if this condition is true. So if age is over 18, so if I enter age as 20, then it would say, yes, this is true, thus you are an adult. And this is done using Boolean variables. If you remember week 2 variables, we say, oh, Boolean, really important. We're going to see them in week 4. And this is why they are so important, because they represent all of these logical operations. Same thing here. For grading system, that's probably how LE simplistic form works. If you got over 40, you can see here we have nested blocks, so an if-else inside of another if-else. If you got over 40, then you passed. If you got under 40, you failed. If you got over 70, you got a first. Else, you just passed. No first. This is an example of a nested if-else, so block inside of a block. There's also you can also have like multiple conditions as well with elif. So if condition 1, then something. If condition 2, then something else. Else, if all of those conditions are false, then something else again. So this is how it works. You're basically ignoring the side that you're not running. So if the name is LE, then I'm saying, yes, it's false, so I'm printing this. If the name is longer, then it's true, thus I'm printing this. So you can see the other side gets ignored. That's why it's called flow control. I'm actually controlling the flow of the code. So that is point one, flow control. And so through flow control, we learned that computers can kind of simulate making decisions. When you take that, the first thing, the most important thing is you have conditions that can either be true or false. And to do that, we have Boolean logic. Now I'm going to present the main operators. I'm going to introduce that term. So the main elements that allow us to write conditions. There are several, and this is just a lecture. No worries, you're going to be able to use them one by one in the workshop where they're going to be presented, plus they're also all in the lecture code. But the main idea of what I'm going to present now is pieces, kind of Lego blocks, that I can use to craft a condition. So if I want a condition that is going to be either true or false, I'm going to use these Lego blocks together, put them to write that condition. The example is, in the age over 18, the blocks I use is age, that's our first block. The second block is the over. I need to check if it's actually over, so the mathematical symbol. And then the third block is 18, the number. So then I put this block together and I have my condition that can either be true or false. So now let's look at what these Lego blocks are. The first one is not A. So we're assuming here that A and B are conditions. They are variables, like Boolean variables. So they can either be true or false. So the first operator here, the first thing we can introduce is not A. That means that if A is false, then not A is going to be true. Do you follow me here? Is it all clear? Yeah? So it's simply something that we apply to make our condition different. If I want to check that someone is under 18, I could, for instance, say, oh, if you're not over 18, then you're under 18. This simply reverses you simply can see how it reverses it. So that's number one, and. Sorry, not. Number two, and. So if we have two Boolean variables, either true or false, A and B is when they are both true. So for instance, if to enter somewhere, you need to be both over 18 and well-dressed. If I'm over 18 and badly dressed, I can enter. If I'm under 18 and well-dressed, I still can't enter. I need to both A and B to be true, still be over 18 and well-dressed. Sorry, bit of a convoluted examples here. But I need both those examples in order to be able to enter. So this means that only in the case of both A and B being true, then the condition A and B will be true. But if A is true and B is false, or vice versa, or if both false, then they're going to be the expression, here, the condition is going to be false. And then we have the mirror of that is the opposite, which is A or B. So if A is true or B is true, then my condition is true. You can simply see it as the mirror, so not A and B, which means that then the diagram is the opposite. So if one or the other are true, or both true, then the outcome of A or, sorry, it should say or, not and here. It's an error. If they're both, then the condition is going to be true. If they are both false, then the condition is false. So we saw three Boolean operators, logical operators. So not, the opposite, and both have to be true, and or, both or one has to be true. And you can see how they work in code. In Python, it's just English. So if A and B, or if A or B, or if not B, or condition. And I can also combine them. So if A and not B. So if you have paid and not have already watched the movie, then you can see it. So if you've not paid, you cannot watch. If you already watched it, you cannot watch. That's an example how these conditions could work on something like Netflix. But they are really important because it's what basically sets the foundation for all the logical operators in computers and in all modern electronic and digital world. And these are operators, so we saw them as logical operators, and or not. But if you think about it, we saw plenty more operators in the past 3 weeks. So now I'm going to present the other categories of operators, and you're probably going to recognize some of them. The first one is comparison operators. We've used that already. So something like, is it bigger than, smaller or equal, bigger or equal, and then equality. You can see here, there's only one important thing I'd like to get your attention on. This double equal here for equality. This is because we already used the single equal to assign a variable, if you remember. So this way, in order to distinguish it, you need a double equal for the comparison. You're going to do a decent amount of errors to do that. Still, developers still do this because they forgot the double equal. So remember, if you do an if and have a condition, remember to use two equals into that if you want to compare, and a single equal if you want to assign a variable. So if I say name is equal to Lorenzo, one equal. If I want to check if the name is equal to Lorenzo, double equal, for instance. The third type is arithmetic operators. We also already saw all of them. So kind of addition, subtraction, multiplication. These are things we used still since day one, where we calculated the temperature in Fahrenheit. If you remember, we had to use these base mathematical operators. And then finally, point 4, the assignment operators. So things such as the single equal and all of these others that are a bit more niche and you don't need to know about. They're basically the same of just using an equal, but faster. So the assignment operator is just equal. So when you have a variable, you assign the variable to something, so use a single equal. Examples here, for instance, we can see if a plus 1 is over 3, then I run something else. Or if a plus b minus c is over 0, then something. You can see plenty of mathematical application for this in terms of prime numbers, in terms of quadratic equations, and plenty more. Or here as well, I can sum them up. So variable 1, variable 2 is equal to variable 1 plus variable 2. This basically puts them together, and thus the output will be 6. So we saw the main point. I think that here, yes. So in the lecture code, you're going to be able at the end to find plenty of examples of operators and loops and if else. So if you just want to have a look, we're not going to go over all of them now, but if you want to have a look, you're very welcome to. By the way, this week is the one with the most content. So you're going to see it's a bit of a bunch of stuff, but no worries too much, just relax. And you're going to have all the time in the workshop with all the workshop leaders if things are unclear. And then regardless, next week, we're going to get some time just to review a bit this week as well from the feedback from last year. This one where it gets a bit more stuff because it's like there's a lot of stuff in logic and there's a lot of concepts to grasp. So we finished with the if-else and the flow control, the simplest flow control, which is the if-else, which is with a condition true or false. But we can also use flow control for more advanced things. One example that I'd like to give you is the one that we saw at the start with the name. So if the name is over 3 characters, yes, you can go. If it's under 3 characters, no, you have to enter a name again. So let's say they do it again. So they put a short name, you say wrong, you put an if-else. Then they put a short name again, you have to put another if-else. Then they put a short name again, you have to put another if-else. And you can see how this can become a lot, like an infinite amount of if-else. You follow? Yeah? Thus, someone, I don't know who, but someone clever invented loops. So this means that rather than writing the same code 100 times, I just say, oh, do this 100 times. And this saves a lot of work. Like imagine, like there's a lot of you. You all received a personal email. Imagine if I had to go and write and send every single email manually to all of you. Probably take a week of work. I just wrote the code for sending the email, wrote a loop, and said for every student in that room, just send the email. So a loop, what it will do is, while a condition is true, I'm just going to keep doing it. When it becomes false, I go out. So the simplest loop is called the while loop. And it's this. So while the condition is true, I just do the same thing again, again, and again, and again. When it becomes false, then I go out and I continue the code. So if we think, it's always useful to think at it as a flow control. So when you see your code, start from the start and go down line by line and think what is happening. Let's say we start, we print something, print hello, and we say, oh, for every student, send the email. So it starts, student 1, send an email. Student 2, send an email. When the students are finished, well, then there's no more student. The condition becomes false. Thus, I continue. So while the condition is true, I run some code. When it becomes false, I continue. I'm like freed, and I run some other code, and I continue. We can look at how we can solve our problem here with the loop. So I still take as input the name, and then say, while the name length is under 3, if it's under, you can see here it's reversed from the one before, because true actually means that it's under 3, thus I need to run it again. So this is the loop part, the part that I will do on repeat. This is the condition. So condition is the name length is under 3. While this condition is true, I just say, oh, your name is too short, put it again. So this way, with just 3 lines of code, so print, input, and the condition, I'm going to write something that otherwise with if else would have taken an infinite amount of code. When the person finally, I don't know, they'll probably get bored of putting the short name. When they'll put a long name, then I just continue, and I can go on and keep doing other things with the code. This way, really simply, I save myself a lot of time. And we can look at an example. Someone starts, put LE. So the name, the condition, is it shorter than 3? True. Thus, I print error, your name is too short. I go here. The name is Linus now. So I go here, the condition. Is Linus shorter than 3? False. No. So I go the other side. I exit the while loop, so I go out. If you remember, here, this is the false condition. I'm exit. You can think about it like a roundabout. I keep going on the roundabout, and then when I get the exit, I go out. So then I print, yeah, hello, Linus, and then I go out and I continue. Maybe I do other actions. This can be used for another example that I believe it's in your workshops. I'm not going to cover here, but it's guess the number game. So if I ask people to guess a random number, I have like the number is 35. And then what happens is, while they don't guess the number, I just try again. And when they guess it, I say, you won. This is another example of these types of loops. I think we have some codes about it as well in the lecture. Yeah, so if you want to look at how it works, it's quite similar in terms of syntax of if else. You use the while, then you put your condition, the symbol, 2 points, and then you have everything that inside is actually inside of the block. So while condition, then username input what is the username, and then this is basically what it does after. So once this loop is finished, it continues here. I heavily encourage you to run this code if you have the time as well, and try to play with it and see what happens. And now for the third and last big concept of the day, for loops. These are still linked to while loops in the terms that we're still repeating an action. But the difference of a while loop, where we're looping around a condition, a for loop will be looping for a number of iterations, a number of time. It is also really important. So what I'm saying is, for 10 steps or for 100 steps, I'm doing something. And this is where maybe for the student example, a for loop will be makes more sense, because I'm going to say for every single student, I'm going to send the email. So if there's 100 students, it's going to go student number 1, email number 1, then repeat student number 2, email number 2, student number 100, email number 100, and then continue. So I'm defining the number of time I want something to run. And I can either do that with a hard number, fixed number, so just say, do this 100 times. So for 100 iterations meaning to iterate, to repeat with some or no variation, iterare, or I can just say through a list, so iterate through a list. So if I have a list of names of all the students, then I say simply go through every item on that list. Let's look at how it works. So let's say I want to look at a for loop to take a sum of the first 100 numbers. I start and define a sum as 0, just starting from 0. Then I say for each I from 0 to 100. This bit is the most important bit, and is the reason some of you get confused. Some people get confused at the start. So exactly here, what is happening is this is a mute variable. This is a variable that only makes sense within this loop. So what it means is we're using it as a way for us to assign it to every value from 0 to 100. So I'm going to start. I'm going to say, oh, I is equal to 0. Each I from 0 to 100. I is equal to 0, and thus 0 plus 0. So if you continue here, what I do for every iteration is I take the sum, so start with 0, and assign it to the previous sum plus I. So here, I'm going to have 0, because the sum is 0, plus I, which starts 0, thus the equal 0. When number I is equal to 1, because it's going from 0 to 100, then I get 0, the sum, because it's still 0, plus 1. And now the sum becomes 1. Then I is equal to 2, because I is literally going 1 by 1 from 0 to 100. And thus, I got the previous sum, 1, plus I, 2, 3. And then I go and continue up to 100. Are you following me? Yeah? So it makes a lot of sense, because what we're saying is only within the block, only within the for loop, we're going to take I and make it run from 0 to 100. This is the same thing logically as saying do this 100 times. The big advantage is that I can stop at whatever moment, look at the value of I, and I know how many steps I took. So it's like saying if I want to do 10 steps, I'm going to do I is equal to 1, 2, 3, 4. Where I am, I did 4 steps, I is equal to 4. We start counting as 0 most of the times, as already presented, so that make sure to not be confused. So usually you have to add 1 to the total value as well. And we can present that in tables. I heavily recommend when you have for loops, if you have any exams or just for the workshop, to use tables. Tables will make your life so much easier. This is how you do it. You put I, the index, iteration. Then you put all the variables here. So what happens is you can even have like 20 variables or any variables you want, and you track their value through every iteration. So in the first iteration, the 0th iteration, my value I is equal to 0, and my sum is 0 plus 0, 0. Second iteration, 1, I is equal to 1, 0 plus 1, 1. You can see how this can make your life so much easier. Like this will save you. If you have an exam and have this type of question, this can really save you. Because you just go down, it's really logical. You take your code, and you say, oh, this is what will happen the first time. So 0, this variable will be this other variable will be this. Then you do the loop again. This variable will be this variable will be this. And you can go for how many iterations there are. Obviously, if there's 100 iterations, you can do the first 3 or 4, then understand what logical rule there is behind, and apply it up to 100. And now, fortunately, I have to show this. I'm really sorry. If it's a problem for you, please close your eyes. We have some math, but we can also calculate that and get the value mathematically. So once you get the first steps, you can get all of the steps. And this is also presented in code. So you have the pseudocode for I in range. Usually we use the in range in Python, which basically means I define a start, so like 0, finish, 100, and a step. By default, I believe the step is going to be 1. So if I want simply to print any number between 0 and 100, in Python, the last number will be excluded. So if I want to go up to 100, I'm going to have to go and put 101. And when I run this, it's going to literally print 0, 1, 2, 3, up to 100. And you can have other examples if you want. It's also possible, as we say, to iterate through a list, which means if I have a list with name number 1 is the first item on that list, name number 2 is the second item, I can iterate and do something for every item in the list. So for every variable, for every box on that shelf, I'm doing something. I'm maybe multiplying it by 2. So if I have a list of 100 numbers, and I say for every number in the list, multiplied by 2. First number times 2. Second number times 2. The only thing I'd like to talk about to close, it's infinite loops. It's really something that I think is a really interesting concept. If you make the outward condition impossible, it will just spin forever, and this will happen. Luckily, most modern computers will have something that realizes something is an infinite loop and block it. But when in early programming languages, and maybe in some cases, you can get an infinite loop. So if the condition will never happen, if you go and count from 10 to, if you just have a counter and say, oh, stop when the counter reaches 5, but you start counting at 10, it's never going to reach 5. The computer will just do this forever. Realistically, I think you can try and do it on Collab and see what happens. Realistically, Collab will block it and say, oh, it's an infinite loop before your computer actually burns. But I think this is a really important concept and shows how programming can sometimes go wrong. There's a lot of classes about how programming sometimes had unfortunately gone wrong due to any type of errors. I mean, the Ariane 5 rocket, I think I mentioned it in week 3, it crashed because of a casting error. So the millions of value lost because they did not convert a float to a string, or the other way around, I'm unsure. But basically, that's what happened. And all of this led to a cascading effect that led to the stabilizer system to turn on while they shouldn't, and the millions-dollar rockets with really bright mind to lose all that hard work. And there's other examples as well. There's more concept to this. I think I gave you already a decent amount of things to ponder. So I'm going to just put them as completely optional. These are not required and will not be in any of the beginner intermediate parts of the course. But I think these are interesting topics. So if you have some time or if you'd like, you're very welcome to have a look. I believe also in the resources on the app, you can look at them or simply search. There are plenty of good resources online. And without further ado, I'd like to give the mic to our guest speaker of the week. So Adam O'Neill, and he's doing a case study about his startup and his work at Meta.
Cool. Well, before I get started, can everyone just like stand up? Up, 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 up. Love it. We love it. And I have a little stretch. I appreciate it's been a very, very long day. And it's what, like 7:40 now? So like have a little stretch. Be happy to be here. I want to see lots of faces and less laptops. And then sit back down when you're happy. You go. Yeah, wait. Cool. Well, if I haven't met you already, my name's Adam. I previously spent some time at Meta, and I'm currently working on a startup between San Francisco and London. My startup is valued at 7 figures. Now, I'm only saying this to not blow smoke up my arse or be an arsehole. I'm saying this because I really want you to lock in for the next 10 minutes, and then it will also demonstrate some of my points. So who's heard of vibe coding? Anyone? There's 1, 2. Okay, good numbers. Cool. So we all know what ChatGPT is. Blank faces. Cool. Okay, I assume you do. So vibe coding is similar to ChatGPT, but instead you're building on your laptop. So this is a terminal, which some of you may have seen before. But what makes this different is this has access to your files on your laptop. So say you're a historian and you want to build something about bone, I don't know, something in history, some really niche thing that nobody would ever know except you. You can do this now by just like going onto your laptop, going onto the terminal, saying, help me build a website for, and then you can sit through and work with Gemini to build that. So like really now you can build anything. And this is like really, really crazy because never in history has somebody with a background of physical education been able to just open up their laptop and start building some website for that. And I want to like really stress, now is the time if you want to build something. The vast majority of you are very young, you've got no responsibility. You can just kind of go fuck it and then try and make something, and if it doesn't matter, you've not lost anything. So yeah, some of the vibe coding. Cool. So these are some of them. There's Gemini, which you probably recognize. Codex is OpenAI's one in the middle. And then Claude is Anthropic's entry to the mix. But the reason earlier I said that my startup was valued at what it's valued at is because the vast majority of my job now is just reviewing AI code. And I do not stress this at all. For those who were just sat behind me, I had a terminal window open saying, help me build a tool for, I was doing enrichment from an LLM, but it doesn't matter. And I cannot stress this enough, because you will have unique insights into the various things that you've walked in life, and you can now build something for that, which I know I've just said, but it's really, really a crazy time. So please build something. Do a hackathon. Hack Southwest is kind of Exeter's hackathon. I think that's soonish. Do you know? Yeah, it's like November.
There's someone coming to talk about it in the last week of Excode. We have 5 speakers and I'm going to talk about it as well.
Great. So please do a hackathon. It's like 24 hours where you get to just sit there and like not sleep and build something. But like, yeah, that doesn't sound very, very fun. But it's really rewarding at the end to come away with something that you've completely made from scratch on the internet, which you can share with your friends and say, yeah, I made that. Okay, to my second point. Exeter is a massive corporate conveyor belt. I guarantee that vast majority of the people in this room, parents, are probably in some kind of consulting or some kind of corporate job, which has been perhaps not glorified, but it's like the status quo. Everyone here probably dreams of Deloitte audit, but people don't even realize roles in startups exist. So this is where what you do is really more fulfilling. Again, we'll talk about it in a sec. But again, you recognize lots of them startups up there, and then big corporate. So I appreciate there's significantly more to doing a job than just a salary, but this is the easiest way I have to convey what I'm trying to say. An entry role at somewhere like Deloitte will probably pay you between 20 and 40K, whereas 11 Labs, has anyone heard of 11 Labs? Nobody. One. 11 Labs is like a voice agent. So they're working on the modal. Instead of typing into ChatGPT, it works by you speak instead. So they can also clone people's voices. Really exciting startup, 15th most valuable startup in the UK right now. But something like a recruiting role at 11 Labs, I appreciate that's USD, but that's 72 to 110. And it's doing almost exactly the same work you would be doing in a corporate life, but you're working at a startup. Now that brings me instantly on to what if I'll lose my job if the startup goes under. Firstly, this is a smaller issue than you think because venture capital fund startups. You go and raise anything between 1 and 100 million, and that will fund your startup for the next, I don't know, depends what your runway is, probably like 2 to 4 years. But if the startup does go under, you will have learned so much and worn so many different hats from all the different jobs that you've done at the startup, which you would not have done if you went into consulting, that you could always just turn around and say, I want to go down the corporate ladder now, because consulting and the corporate ladder will always be there for you. Whereas the time to go and try something new and be different will not always be there for you. So my ask to you is to be different. You're a hell of a lot more experienced than you actually think you are. And you'll make a massive impact into the startup culture, which you probably didn't know existed until today. I'll hang around for about 10 minutes or a bit longer. So if anyone wants to chat or pick my brain or push back at anything I've said, please do. But yeah, thank you.
Very much. Amazing. Yeah. Quite insightful. So to close the session, short recap and then the code. So this week we talked about computers making decisions. It's kind of weird to think about it, but the way they make decisions is through flow control. So they use conditions, logical conditions, to make things happen in a case or different things happen in other cases. The base flow control logical thing is if else. If something is true, then something happens. If it's false, if it's not true, then something else happens. The second thing we saw are loops. And in loops, we saw while loops. So while a condition is true, I do something. When it becomes false, I do something else. And for loops. So for a number of steps, I do the same thing. When I finish the number of steps, I do something else. So thank you all for coming. And now I'd like to give you the code. Well, first the code and then the gaming competition. You want to enter on the app. This is the code. You can fill in, write the questions, and then also put any feedback or any notes. So the gaming competition. Are you done? Yes. Okay, great. So the gaming competition this week, it's as all the others week, beginners, intermediates, and advanced. They're all based on various types of games. You can skim through if you want to the beginner advanced or spend more time. Sorry, the beginner intermediate. But the advanced side, this is where the actual fun is. So we're going to do a completely optional gaming competition. So you're going to be tasked to create a written game. So no need for graphics or anything. You can do kind of a game in that you play on text. And the game has to be kind of playable and submitted in the next 2 weeks. And the winners, so the first prize is going to be a trip to the Google office or a £50 cash equivalent. The second prize is going to be £30, and the third prize is going to be £15. This is going to be the price. You can all submit through a Google form. It's open to everyone, entirely optional. And last year we had some amazing submissions, like really fun games. There's no limit as long as it's like widely professional. You can use AI, you can copy existing games, you can do whatever you want. You're going to be judged on kind of three, I think. Yes, three main things. The first one is the experience of playing the game. So last year we did as well, but no prizes. So you're lucky if you're the first year. Thanks to Google and the alumni fund that we have like proper prizes. So I'm going to go play every single game as like not a developer, just like a player, and see how it goes. And that's going to be number one. The number two is code quality. I'm going to look at the code. And this is where I will realize if the entirety of the code is just ChatGPT. Like last year, I literally had a thing, ChatGPT, not ChatGPT, and I could know every single thing. What I mean by that is you're 100% welcome to use ChatGPT. I mean, I think that kind of was the whole point of the talk. But what matters is how you're going to use it to stand out. Because everyone in this room can open ChatGPT and ask it to create a game. But if you use it well, I will realize, and I will give you a bonus point for that. And then three is the complexity, which does not mean how complex the code is, because on the contrary, sometimes if you are able to make something complex visually, or in the game, but simple in code, that's also bonus points. But the complexity of the game, this means things about edge cases. If you ask my name, what happens if I put one character? What happens if I put 100 characters? What happens if I just click enter and not actually put my name? So if you think about these cases, if your game is actually playable, you'll also get bonus points. So you're going to get a grid, mark all that, myself and a couple of people from the Excode team. And then in 2 weeks, in 3 weeks, so in the final week, the celebration week, when we have also the certificates, we're going to announce the winners live. Also, everyone that participates, regardless, will receive something on their certificate. So that's also a bonus thing. And even if you think you maybe don't have the level to win, I recommend participating. I mean, it's a project, you can do whatever you want. Give you some examples here. So it's a text-based adventure. So it means that, or whatever, the type of the game doesn't matter, but it needs to be text-based primarily. You can use ASCII, but But basically the idea is you don't have to use a game engine. You have to do everything in Python. So like this. So the game has to be playable like this. If you have any question, you can ask the workshop leaders. You can send an email as well. Yes, that's all for this session. And I'll see you all next week.